So taken into consideration, this is the sample. Let's imagine this is a tooth. This is what we need to embed it in. This is a compound. It comes in usually different shapes, but this is the one we're using now. All we need to do is just put hot water over it, boiled water preferably, so we can change its shape to go around the sample. Usually the tooth has very complicated morphology. We do this in order to make it to have flat surfaces, so the sample will not move while we're cutting it. As you can see now, this used to be very hard. Now it's very flexible. What we do is we put the sample in a way where it is long enough for the blade to cut, because the blade's going to cut this in this direction, and it's going to be held like how I'm holding it now. We have to make sure that the morphology resembles a cube. So with flat surfaces, if you get something like this, just dip it in the hot water again, and then it can become soft again. So here we go. This is a perfect example of how to embed the sample. Now we need to wait about a minute or so the compound can harden again. And then we have to, and this is the holder. It is usually placed on top of the machine. There are 3 types of screws. So this is the medium one. You can find all the screws here. So this is, for example, the long screw. There is a couple of each depending how big your sample is. So there is a couple of that size, a couple of this size, a couple of very small ones like that one. So it depends on how big your sample is. You have to put it in the holder. Now we're using the middle one. It should be fine for our sample. And using an Allen key. There's no names on the Allen key, so I can't tell you which one to use. You have to just look. We have also different sizes of Allen keys there. So we just untighten these screws so we can move this part of the stage. Untighten it in this way. Now, until you have enough space so you can place your sample. As you can see, this is not big enough. You can unscrew it further. A bit further. I think that's perfect. Now it can be placed here. That's why I said we need flat surfaces so the sample will not move. Now we press it a little bit and then we tighten the screws again. Don't over tighten it because the compound usually breaks under pressure. So just enough so the sample will not fall down while cutting. So you can test this by trying to lift it with the sample and also try to move it about. See, it's not moving at all. So this is perfect now. Once we've done this, now we can place it in the machine. So this part is done. The next part is to open the machine. So usually you can turn on the switch from here if it's off, and there's a switch behind there. It's very hard to see, but it's just where the wire comes in. Now make sure that this is down when you turn on the machine, because it needs to calibrate. It needs to find its position in space. So we wait for it until it calibrates to see what it is. And while this is doing it, we can see that the main menu, this is the first menu you have. It has 3 options. We don't need the 2 options below. We choose the cutting method. Now to control this menu, we use these buttons here, the green ones, blue and pink ones. We don't use the yellow buttons to control this menu. We'll use it later. Now we press enter here. This is enter. So enter goes forward, escape goes backward if you ever make a mistake. As you can see here, the next menu, it's asking me to select the cutting method. It means select the blade. As you can see here, there are two blades we use usually, the M0D08, M0D10, so 8 and 10. I have an example of a blade. This is the mod 10, is the bigger one, and this is the mod 8. The difference between these two blades is the thickness. This is 300 microns thick, this is 150 microns thick. Usually we use this if we are cutting a precious sample and we don't want to lose and we don't want to destroy much of the sample. But this is the problem with this is very fragile. As you can see, this one is broken. We have a new one, and this one is more durable, so it's better to use this all the time. Once we've and this one is already, as you can see, now we can open this because it's already calibrated. This one is the mod 10. This is here are where the water comes. Make sure they are right where the blade is, so it kind of make it colder, it prevents heat. Now we know that it's mod 10. We go up and down, page up and page down to select the blade. So from mod 8 we go down to mod 10, so that's how you select up and down. Mod 10 and press enter. Now we get the cutting method options. This confirms that we're using mod 10. We set the speed here, we set the feed, we set the force and the water. The water has to always be on. How do we know this information? Well, usually we have this booklet here beside the machine. In addition to this booklet as well, whatever I'm saying is all there. On page 41, you can see all the different materials that you need to cut and what are their recommended cutting parameters. So in case of teeth, it's the ceramics, minerals and crystals, and it tells you how much hardness it is. We don't need to worry about that. The force limit, so if it's low you use these feed speeds, if it's high you use these feed speeds. Also the wheel speed depends on how high and low the force is, and everything is there. So now, since this is not a tooth and this is just a tutorial, we will go what already is there, 3000 RPM and 0.25 millimeter per second. Just to explain, the feed is how fast does the holder move towards the blade, how fast. So this is moving now 0.250 millimeter per second. The wheel speed, or the speed here, is how many rounds per minute does the blade operate at. Now it's time to mount our sample, or to mount our holder into the machine. Put this away. We're using the same Allen key that we use to tighten these screws. We need to slide. There are two teeth here, and there is, as you can see here, it looks like a V-shaped. We have to put this V-shape between the two teeth, like this. Make sure that you're always holding the sample. Don't just leave it. I mean, now it's not going to fall, but if it falls, it will destroy your sample. So always hold it, and while holding it, you tighten this screw here with the same Allen key. Done. Not too much, just enough so it doesn't move. This is perfect now for mounting. The tooth will cut in this direction. The second part is now where this menu comes into action. This menu here controls the holder. So this one moves the holder in the x-axis, and these two move it in the y-axis. Why do we have 4 buttons here controlling the y-axis? Is because in the y-axis we need to be very precise. So this one moves the holder fast. So if you can see here, when I press this button here, the holder moves towards the blade. You see, it's very fast. If I press the button, the low speed button here, it moves slowly. You can't even see it moving. In the Y direction, we have only one button, moving it backward and towards the blade. Now we need to start cutting, so we have to tell the machine now where the tooth is, where to start cutting from. So using these controls, we move the sample, as you can see, towards the blade to where we want to start cutting. So we move it in Y, and then move it in X, then move it in Y. We get it as close as possible to the blade, not very close because you don't want to touch the blade at all. It's a very fragile blade. It is 450 pounds, so we don't want to break it. Here we go. So that's where I decided to cut the tooth. So that's the position where I want it to cut. Now to tell the machine this, we need to tell the machine to set a 0 to set a relative position to the 0. So now it's in the Y. To change it to X, we just press any of the X buttons. I think I've been confusing X with Y a lot, but you get the gesture. The X, so if I press any of the X button, this will change into X. And if I want it back to Y, I just press any of the Y button, up or down, it will change it to Y. It will not move anything, it will just change the menu. Now let's start with Y. First we press reset, F1. If you can see, it's very hard to see with this display. So we press reset, and then as you can see here, the relative position became 0. Now the relative position is 0. And then we move to the X. Again, press any of these 4 buttons. Press this, and then now the X. Same thing, we do the same thing. We go to the reset button, F1, and now both of them are 0. Now the machine will know that I will start cutting from 0 in both A and Y. The next stage is to set the relative, to set the stop position of Y. So we move the sample away from the blade, because we can't move it towards the blade, we hit it, and then we move it towards the blade when we have enough space to do so. So we moved it away from the blade, and then towards the blade. This is, we're going to tell the machine when to stop cutting. So just make sure that your sample is within, as you can see here, it will stop cutting here. If you look from the up, you see that the sample, it will be cut fully when we, if we stop here. Now to tell the machine that we need to stop cutting here, we press F2, set stop. So set stop position. And now to make sure that this is correct, the relative position and the stop position will be the same in the Y menu. Now we've told the machine where to start cutting, so now all we have to do is move it to relative 0, so it will move to the 0. Make sure at this stage that this is on the Y position menu, because if it's on the X position menu and you press F3, move to relative 0, it will hit the blade and it will break it. Making sure that it is at Y position, then press F3. Now the sample will automatically move to where we've set it initially. Now we go to the X menu. Now it's X menu. Again, do the same thing. F3, move to relative 0. And now it's back to where we've set it. Now we are ready to cut. Before we start cutting, it's a good practice to make sure that we have enough water in there. There is enough water. Usually it has to be 1 centimeter or less of water there is, and should be clean. Now it's not very clean, I will clean it after this video. And we also have to make sure there's a nozzle. I don't know if you can get it with the camera. There's a nozzle at the end there. Yeah, you can see. This nozzle has to be inside the water. So it has to be inside. Sometimes it gets stuck. So now it's stuck. I don't know if you can see it. A little bit. So just keep moving it back and forth until, so now it's perfect for this demonstration. Okay, now it's in there. So the nozzle is right in the water. Here we go. And also you can diagnose this problem. If there's no water coming out from these two, then the nozzle is not inside, or there's not enough water there is. You have to make sure the water is always over the blade. Now we put this down. It will not run if this was out. we press the green button, start. And then it will start cutting. As you can see, there is enough water. The water is flowing nicely. It's cutting. If by any chance you hear a strange noise or something is not going very well and you want to prevent damage, you can press the red button and it will stop. Or if you when you open this as well, which I don't, because sometimes water will come all over you, so I suggest that the user just lift this if you want to act really fast. But when you press the stop, everything will stop anyway. Now we have our first slice here. As you can see, it's cut perfectly. Now this one, we don't know how much, what's the thickness of this slice, because it's the first slice. Now if you want to cut sequential slices, we will be able to know the exact thickness. So the first slice you cut, we don't know how much. Usually this one is done for experiments that they don't require the exact thickness. But for experiments that require, for example, if it's an X-ray absorption method where you need to know exactly how much X-ray is going through the sample, you need to know the thickness. To do this, we need to move the sample. So let's open this so we know what we're doing. We need to move the sample by, let's say, 1 millimeter. Say you need a sample thickness of 1 millimeter. So you have to move the sample in X towards the blade by 1 millimeter. So let's go to the X menu. That's the X menu. Now it's 0 because we've set it to 0. Now we need to change that into 1 millimeter. Now it's 1. Then it will not cut 1 now because the blade also is 300 microns. So we need to add, so F2 here, as you can see, F2 adds the thickness of the blade. And we mentioned earlier that thickness of the blade is 300, so it automatically added the 300. Now we know exactly what the thickness that is going to cut at. We close this again, and then we start cutting. Press the green button. Okay. So now, before we stop, this is finished now. Just here it tells you how many the remaining time. Okay. Now this is part 2, which now the sample just finished cutting. It's 1 millimeter slice. Now to take the sample out, we take it out of the blade, so away from the blade, backward, just like that. Leave enough space. You don't want to touch the blade at any point. We use the same Allen key that we used previously. We untighten the screw, keep holding the holder, and then slide it towards you. Then you, same Allen key, unscrew these screws, take your sample bag, and then leave everything where it was. And now here's your sample. And usually, so sometimes the slices, they get, as you can see here, it's good that that happened in this case. The slice fell below over there, so make sure if you can't find the slice, don't worry, you just need to take this out, and usually maybe it just went under. So this is, you can take this out, no problem. So now we have these two slices. This is 1 millimeter thickness, and the second one was unknown thickness. Now to take your sample away out of the compound, just dip it in the hot water and it will be soft again and you can take it out. Then afterward we need to dry it with tissues. 2 tissues is enough. And just dry it as such. Just make sure there's no water in there and it's nice and tidy for the second user to use it. If there is any water coming out, any water that came on the machine itself, just clean it as well. Just make it presentable, the same way as you like to find it when you come and use it. Usually, I advise people to leave this on, open, sorry, not on. So you will not have humidity and you will prevent rust this way. And and make sure you sign to this logbook as well. Thank you very much. After we've cleaned it and we make sure this is open, we just close it from the back, same way as we turned it on. And then we also may turn it off from here as well. And now it's ready for the next person to work on it. Thank you. Okay, here's some safety tips. Make sure that these nozzles are always down before you close the door, because if it's up and you close it forcefully, these nozzles will break and it's very hard to replace them. These nozzles can be, if they are stuck or if they're not producing any water and everything is correctly, they can be taken out as such and they can be cleaned. Both of them can be taken out if you ever want to take them out. So you can clean them, maybe clean the holes where the water comes out from. You can also take this out, and if the water is not going inside the machine, maybe this is blocked here, this can be taken out, this part, and can be clean as well. Sometimes this gets blocked if you have too much waste there. Make sure that whatever you do, so when you are cutting the sample, this, as soon as the blade touches this, it will break. The blade is no more, and that's 400 pounds gone down the drain. So this has to not touch always give space, so that when you saw me preparing the sample earlier, I left a huge space from the sample, from where I want to cut to where I want the sample to be held, because I don't want it to be close to the blade. I want it to be as far from the blade as possible. You don't want it to be far, because then you will have lots of loading forces and it will break your compound. But this is a perfect example of how far it should be away from the blade. Around, I say, 2 centimeters to 3 centimeters from the holder to where the sample you need to be cut. If you break in the instance where you break the blade, don't worry. I mean, try to prevent it, but if it happens, it happened. Report it straight away. Just go to Jerome or the lab manager at any time and report it, because if you don't report it, then the next person who want to do the experiment, they will come and they will suddenly find out that there's the blade is broken and there's no replacement blade. This will delay their experiment by at least a week by the time the new blade is ordered. So make sure, blade broken, don't be scared, don't hide it, it's okay, nobody will charge you. Just go to Jerome and order a new blade, and that's it, that's all you need to do.